With polynomials such as this one, it may be tempting to expand all of these out to find the degree, the leading coefficient, and the constant, but that might take too long. There is a shortcut. Let's go through it. So first off, for a, we've got p of x is equal to 2, and in brackets 3x minus 1, this is squared. And then we have another set of brackets, which is 5x squared minus x plus 1. When we're finding the degrees, the x is the only part that matters. And we've got 3x minus 1 squared. This can be broken down to, well, once we get rid of the rest of this stuff, we've got x squared. Next up, we have 5x squared minus x plus 1. When finding the degrees, the only part that matters is this part right here. You can get rid of this, you can get rid of this, and this as well. So what you're left with is x squared times by basically x squared. So your degree is going to be x to the power 4. The degree is 4. As for the leading coefficient, let's write this out. We've got 2, and then we've got in brackets 3x minus 1 squared. And we've got 5x squared minus x plus 1. This 2 is important because it's going to be multiplying everything else, so you can bring that down. As for this next set of brackets, the only number that matters is the one that's attached to the x. So you can ignore this part right here, and of course we don't need the x to find the leading coefficient, so you can ignore that as well. When we scrunch this down, it's going to be 3 to the power of 2. In the next set of brackets, the only coefficient that matters is the one in front of the x squared. In this case, it's going to be that 5. So you can bring that out as well. The rest of this stuff does not matter. So we've got 2, and then we've got 3 to the power of 2, and we've got 5, and these are all being multiplied together. Bedmass rules apply. You do this part first. 3 to the power of 2 is 9. And you're going to multiply all of these together. 2 times 9 is 18, times 5 is equal to 90. Your leading coefficient is going to be 90. Next up, we've got the coefficient. So again, we have 2, and we get 3x minus 1 squared, 5x squared minus x plus 1. Well, we know the x's aren't going to matter at all when it comes to a constant, so you can get rid of all of the x's. Okay, all the other numbers are going to remain, even including the 2 on the outside, because it's going to multiply whatever's on the inside. So if we scrunch this down, we've got 2, and then we've got minus 1 squared, and then we have that 1 left over in the other set of brackets. So, BADMAS rules. We have negative 1 squared, which is just going to be 1. 2 is going to multiply that, and this is also going to be multiplied by 1. So your constant is going to be 2. If you expand and multiply this right here, what you're going to end up with is p of x is equal to 90 x to the power of 4 minus 78 x to the power of 3 plus 40 x squared minus 14x plus 2. Now, the degree is found right here. This is the 4. The leading coefficient is found right here. And the constant is found right here, which is exactly what we found using the shortcut method. Next up in B, we have p of x is equal to 2, and in brackets we have 3x minus 1 squared, plus another set of brackets, which is 5x squared minus x plus 1. First off, we need to find the degree. So we've got 3x minus 1 squared plus 5x squared minus x plus 1. In this case, this x is the most important part right here. You can get rid of the rest of it. So you're left with x in brackets squared. Over here, the x squared is over on the far left is the most important part, because if this was by itself, the degree would be 2. So you can get rid of all of this stuff right here, it's not necessary. So you have x squared in brackets. So when you're done, you have x squared plus x squared. And if you add those together, you've got 2x squared, and this exponent here will give you your degree. So the degree in this one is going to be 2. Next up, we have to figure out the leading coefficient. So we have 2 and then 3x minus 1 squared plus 5x squared minus x plus 1. And of course, this is p of x. Now, when it comes to leading coefficient, anything attached to the x here is going to be the most important part, and over here the leading coefficient is going to be important on this x right here because it's the one to the furthest left. So you can erase everything else, even the x's, they don't really matter, just the numbers attached to them. So what you're left with is 2, and in brackets you've got 3 squared, and then over here you got plus this 5 after you've eliminated everything else. So bed mass, again, 3 to the power of 2 is 9, so it's going to be 2 times 9 plus 5. This is going to give you a leading coefficient of 23. Next up, we have a constant. So p of x is going to be 2, 3x minus 1 squared plus 5x squared minus x plus 1. With a constant, anything with an x on it doesn't matter. We can erase all of that. So we've got this 3x, get rid of it. We've got the 5x squared, get rid of that, as well as the negative x. What you're left with here is going to be 2, and in brackets negative 1 squared, plus we got a positive 1. So bedmass rules apply. We got negative 1 squared, it's going to be just 1, and this is going to be multiplied by the 2, plus 1. So 2 times 1 is 2, plus 1 is going to be 3. So your constant for b is going to be 3. If you expand b out, p of x is going to be 23x squared minus 13x plus 3. The degree is found right here, okay, so that's going to be 2, just like we said. The leading coefficient is found right here, and the constant is right here.